Hi, good afternoon, Arvind. How are you?
I'm fine. I'm fine. I'm really very happy to see you
That's
on
great.
board.
That's great.
On board. Uh, uh, Good afternoon, everyone, and all the participants who have joined. I believe there are 121 numbers of participants who have joined for this webinar on increasing the resilience of Indian vernacular houses for earthquake, cyclone, and floods in a sustainable way. The topic is very interesting, and my uh, class fellow uh, is also from Pantnagar, and I really I'm happy to see. I'm really glad that he is on board to deliver this important topic. And I'm 100% sure that all the participants will definitely enjoy, listening him. He has a very, keen interest on the subject. He has done a lot of studies on this subject, and I'm really happy to see that he is going to deliver this webinar. Thank you very much. Thanks for all. Now I'm handing over this to program coordinator, Mr. Pankaj Gupta.
Good afternoon, everyone. I hope I'm audible since I'm sitting somewhat far away from the screen. Am I audible, Deepakji?
Yes, you are audible, Pankaj.
Good afternoon and welcome all of you. In fact, this is the eighth webinar in the series which BMTPC has been conducting over a period of last maybe 10 months. We normally do this type of webinar once in a month and bringing the experts from the relevant fields, and we take basically topics on the new construction materials and technologies, broadly on the focusing on the housing and also on the sustainable materials, energy efficient materials for the sustainable built environment. So, including the thermal comfort and all. So, under that broad theme, we invite our experts from various technical institutions, research organizations, and sometimes from the industry also, so that we get a wide spectrum of speaker and experts for our audience. And there is a possibility that some of you might be joining the earlier seminars, webinars also, because we keep on sending the invitation to all the earlier participants also. So with this small introduction, and BMTPC for the new participants is Building Materials and Technology Promotion Council, which is a autonomous body under Ministry of Housing and Urban Affairs, Government of India. And our main mandate is to basically identify, evaluate, and promote new construction materials and technologies in housing sector. And apart from the disaster resilient construction and techniques, and we have been involved in the biggest housing program of the world, if I can say, the Pradhan Mantri Awas Yojana, as a appraisal and monitoring agency and the technical partner of the ministry. And capacity building and is also one of our main activities to disseminate all this information to various stakeholders, and this webinar is part of that dissemination activity. With this small introduction, now it is my privilege to introduce Dr. Deepak Bansal, who is our expert today, and he will be taking the lecture on increasing resilience of Indian vernacular houses for earthquake, cyclone, and floods in a sustainable way. To start with, Dr. Deepak Bansal is currently serving in Housing and Urban Development Corporation Limited, HUDCO, which is a central public sector organization of Government of India, and in the capacity of regional chief for the Jammu, Kashmir and Ladakh region. Uh, he is having more than 3 decades of experience in civil engineering in built environment. He is BTech in civil engineering, MTech in structural engineering, construction management, disaster management, and done his PhD. He is governing council member of many national and international professional organizations. He has done consultancy and PMC for many national and international projects in collaboration with organizations like UN Habitat, International Red Cross, JICA, JBIC, ADB, UNESCO, to name a few. He is also honorary advisor in NGOs and engineering colleges. He is an experienced professional for project financing for built environment, housing and infrastructure area. And he has done projects pan-India, having experience, pan-India experience he is holding. Dr. Bansal has presented many research papers in various peer-reviewed international journals, indexed in SCI, SCIE, ESCI, ASCE, besides presenting many technical papers in international conferences, seminars all over the world. He has written a technical book on improving resilience of Indian rural houses and few chapters in other technical books. His main focus of work is sustainable built environment, especially housing, through intervention of structural engineering, alternative construction materials, and maintaining local safe and sustainable vernacular construction practices to promote local construction materials, skill upgradation, and economic development with reduced carbon footprint. He is interested in spreading awareness about safe, cost-effective, vernacular, durable, and carbon-neutral built environment. With this introduction, it's my privilege to invite Dr. Bansal and to start his presentation.
Thank you, Pankaj, for such a nice introduction. And thank you, Arvind, and a special thanks to Prashad Sahab. After a long time, Prashad Sahab is visible now. So, good afternoon, Prashad Sahab. So, with this thing, I'll share a little experience in built environment. Since we are into affordable housing, so we go for horizontal. Within the permissible FAR, we go horizontal and make high density development consisting of row housing of affordable in nature using the vernacular materials. Since India is prone to many sort of disasters, so I'll explain a few points which we planned and designed in these houses in different parts of the country. So let me share my presentation.
I would request all the participants, we can keep the questions at the end of the presentation, or meanwhile, if you have something in your mind, you can put that query or questions in the chat box. We will take up, I think, will be better. We will take up everything at the end of the presentation. Thank you.
So, welcome to all delegates and apologies for this glitch. So, we will be talking about on increasing resilience of Indian vernacular houses for earthquakes, cyclones, and floods in a sustainable way. Next slide, please. We know that India is prone to almost all types of disasters: natural, man-made, industrial, whatever. So, in the natural disaster, we are prone to earthquakes very frequently, cyclones very frequently, flood very frequently, droughts many times, famines many times, landslides frequently, forest fires, tsunami, and cloudburst. So, out of these, few disasters can be manageable, like earthquakes, cyclones, flood, landslides, tsunami, cloudburst, and lightning. And there are many Indian standards and good technical literature available to deal with such type of disasters. So out of these disasters, cyclones and floods are more serious in terms of loss of life and property, and worldwide also. But however, what happens that in urban areas, earthquake is considered to be more serious because of the more level of economy. The second slide, please. I have presented few pictures of the disaster rehabilitation work where I was personally involved. Like the first one, top left picture is a collapse of the building in Sikkim. The top right is a tsunami case. Bottom left is again a picture of a collapse of a building in Sikkim. Right bottom is a monastery in Sikkim. These is collapsed by earthquake. This is the famous case of a collapse of building in Turkey, where the intermediate floor just gave way because they did not have the requisite shear capacity. Next slide, please. We all know that what are the causes of disaster, so we can skip this slide. Next, please. Identification of risk is very important because when we do land planning, we define certain areas which are safe for habitation, certain areas safe for keeping our very high importance equipments like nuclear facilities, like transmission towers. So land planning is being done with the identification of these risks. Based on that, the urban local master plans and zonal plans are being prepared. Next, please. This is the seismic map of India showing the earthquake. This is slightly old because in 2025, the most rigorous earthquake map of India was presented, but this will be withdrawn in April 2026. So till now, we are following 2016 of seismic zone of IS 1893. Next picture. This is the tectonic moment. Next, please. The seismic zoning map of India, which is showing the acceleration, peak ground acceleration, probability out of earthquake in different part of the country. Next slide, please. This is the wind map and flood hazard map of India. Next slide. So some of the earthquake where flood cases where I worked was in Uttarkashi in 91, Latur 93, Jabalpur 97. Jabalpur was the first urban earthquake after so many years. Although the intensity and magnitudes was low, but the impact of disaster in terms of understanding and importance of earthquake was very, very large. After that, Chamoli earthquake, Gujarat earthquake in Jammu and Kashmir, Andaman and Nicobar, Sikkim earthquake. Next, please. In this map, I had marked said natural disasters so that we know which area is more prone, which area is less prone. Next, please. The super cyclone. Although it seems that super cyclone Orissa with the maximum wind speed of 260 km per hour was highest, but if you see IS 875 part 4, which says the maximum wind speed, basic wind speed is 55 meter per second. So which roughly translate into 55 multiplied by 3.6, roughly 180-190 km per hour basic, and design speed may be much higher. So although the super cyclones were called and they have massive wind speed, but Indian standard has sufficient safeguard given in that to design such type of buildings in these areas. Next, please. The floods. I got an opportunity to work with these few floods in this, like Northeast flood in Mumbai 2005, North India 2008, and flood in Kashmir in 2014. Next, please. Now, so we have discussed, we have seen that, what type of disasters are happening in different parts and what are the casualties and what is their magnitude. But the Bureau of Indian Standard has prescribed engineering design to design facilities in these areas and to deal safely by designing safe buildings with different type of importance factors. National Disaster Management Authority of India has also given some guidelines to design different type of buildings which are in compliance with the Indian standards, but these are more elaborate and more, pictorial forms. So understanding of the guidelines of NDMA is much more easier than the guidelines given by Bureau of Indian Standard, but they are basically the same guidelines. The next slide, please. So disaster management has been done by two approaches. One is the planning approach, second the design approach. The planning approach is this thing that we identify the piece of land which is prone to various type of risk. Like if we are designing any building in the Himalayan part, like in Kashmir or Andaman, then we know that earthquake is very high in this region, so we can avoid having low economic activities in this region or designing buildings with the theory that building may get severe damage, but they should not collapse. Second, the engineering design. When we know the forces coming on the building out of this disaster, then forces can be safely transferred to the building and building can be designed to withstand such type of forces. So these are two approaches, planning approach and design approach. In the planning approach, land use zoning has been done. In the engineering design approach, the building has been designed for known forces out of these disasters. Next slide, please. The role of administration is very broad in planning design. The enforcement has to be done, checking the quality of building infrastructure, education and housing, relief and evacuation. They have to do temporary shelter in case of any disaster. They have to supply food and medicine. Emergency communication and transportation has to be established. Psychological counseling and social issues has to be dealt. And long-term rehabilitation and retrofitting has to be done. Next slide. Engineering issue. For engineering issue, we need to understand the type of disaster and their maximum probability of forces coming on the building. This has been given in Indian standard. So these forces has to be transferred to the building safely, horizontally, vertically, diagonally, and then building design has to be done. Next slide, please. I think we can leave all this literature coming directly to the pictorial form where the interventions being shown. So you can leave this slide and next slide, please. These slides will be available to all for later understanding and later discussion. Next slide, please. Right, design philosophy. Building has to be designed economically to resist the forces of earthquake and cyclones up to a satisfaction level without failure. In flood, tsunami, and landslide areas, buildings are to be designed in safe places. Because in the flood we can design, but scour level and water pressure is too high to design ordinary building. But some important building has to be designed like transmission tower, evacuation center, bridges. Then this can be designed as per the highest flood level and the water velocity and the scour level. Soil investigation is to be done, which is the most important part of design. Without soil investigation, we cannot judge the behavior of foundation in different type of loading conditions. Wind forces, earthquake forces, snow loads are to be calculated. These forces are to be applied on the building as per the serviceability criteria to resist, so that building can resist these forces within allowable deformation. However, important buildings are to be designed for higher forces so that there is no hindrance in working with buildings like hospital, communication, and utilities. All the infrastructure is also to be designed so that people can be evacuated. Transport arrangement is to be smooth. Fire emergency vehicle has access to the affected part of the area. Next, please. There are various standards of Indian standard which are applicable for different type of disaster designing of the buildings. Like for earthquake, IS 456, which is a basic RCC code. 1893 is the earthquake code. 4326 is the ductility code. 13920 is the design code. 13827, 13828, 13935 are the code for improving resilience of the buildings. Like for cyclone, IS 875, CED 57 guidelines, IS 15493 and building bylaws. For the flood, IS 13739 and building bylaws. Building bylaws means that land planning, land zoning. For landslide, IS 14496, IS 14680 and building bylaws. For tsunami, coastal area regulation zone, CD 39 minutes and bylaws. Next slide, please. Factors affecting buildings in earthquake: building configuration, sizes and position of opening, building materials and mortar, rigidity, ductility, type of soil and water table, construction quality, weight of the structure. IS 1893 has given two major recommendation about the symmetry and opening of the building, which is further being detailed in IS 4326 and 13920. So which are very, very important, and these as a thumb rule, if we follow them, then the building will be generally more safe. Next slide, please. The adequate depth of the foundation from soil, minimum 500 in NGL, unsupported wall length, all these things have been given in IS 1893 and 4320. So I'll skip this slide. Next, please. Yeah. This is important. The shape of the building, T shape, L shape, U shape, X shape buildings, these are more prone to failure in case of earthquake as well as wind, because the mass in one direction is asymmetric to mass in other direction. So these buildings should not be designed in this format until unless these are especially required for some aesthetic reason or some other reasons. But if this can be designed, then there has to be some separation joint between two unsymmetrical parts, so that unnecessary torsion should not be introduced in the other part of the building. Next, please. Like this vertical. Here we see that these are different type of frame. This is a shear wall based frame. This is a moment restraint based frame. This is a brace frame. So these are optimal design as per the requirement. Either we can go for shear wall, we can go for moment restraint frame, or we can go for braced frame. So these are all good. That depends upon requirement. That depends upon design. Next, please. Now coming back to vernacular houses. So as per Indian typology, there are many houses in rural India which are mud houses, which are straw houses, which are stone houses, which are weak brick based houses. Some are done with mud mortar, some are done without mortar, some are done with cement mortar, some are done with very weak cement mortar. So here the recommendation of the Indian standard is that wall length to be less than 10 times of thickness. So this is general check on the slenderness ratio of the wall. That wall length has to be less than 10 times. If wall length is more than 10 times, then we have to provide some bracing. Buttress is between a large wall, like this is the bracing is the buttress wall. Height to be 8 times the wall thickness. Here again the slenderness ratio of the wall has to be seen. The corner buttresses has to be provided. Door window opening has to be kept small and away from the corners. Distance between door window and from wall at minimum 1200 mm. And seismic bands. Seismic bands and the plinth level as well as the lintel level as well as the roof or eave level has to be provided. Next slide please. Like in this masonry we see that continuous joints. This should be avoided. Here we see that there is no check on the slenderness of the wall. So some band has to be provided. Why this band has to be provided? Just to keep check on the slenderness ratio, aspect ratio, so that in case of any high wind or in case of any earthquake, the whole structure behaves like a one and forces are being transferred in different directions without affecting the structures so that it can collapse. Next slide please. Here again, what we see in this picture that the height of the building is very high without any break in the height. Here height is okay. Here door is also positioned very close to the corner. So what will happen that all the stress concentration will be here and probably this part will collapse. Number of openings are also high in this building. So what will happen that the cross section required to transfer the load is very less compared to this building. So this has to be seen in designing and construction. Next slide please. Here again, what we see that all log axis of the column is aligned one direction. So what will happen that this axis is very strong, but this axis is weak. So earthquake can happen from any direction. It can happen from this direction. It can happen from this direction. It can happen from this direction. So in this case, this is good. This case this is weak. In this, the columns are being oriented in different directions, so that the moment of inertia of this building more or less equal in both the directions. So this will stand good in case of any good earthquake or good wind. Next slide please. Here what happens that soft story. Soft story means that the building which has very less resistance in terms of shear. So here this shear wall is coming, but here shear wall is not coming. What happens that when we design some building for some especially commercial establishment, then they want us that because of this big facade, they would like to have some glass so that all store is visible from outside. So they insist on removing the shear wall or the load bearing member on the ground floor or maybe on the middle floor. But this breaks the symmetry and the load path of the structure, and all the building comes like a pack of cards in case of earthquake because of the soft story, all the concentration load here, and this gives me. Next please. Here again, either we can provide bracing to make building more strong. We can provide shear wall, one part or two part, full part. Actually, it should be through from bottom to top. So that is the ideal way. But that depends upon design, that depends upon load. That what is the ideal situation in such type of cases. But of course, this arrangement is not good because here it is very clearly visible that this is a very soft part. Next slide, please. When we come to building construction using the stone, so what happens that stones comes in the irregular sizes. So they are being fitted like anything. But there is no proper connection between cross walls. So there are two ways, that one to provide this dowel bar and one to provide the vertical steel bar, which is again being demonstrated very elaborately in IS 4326. Next please. Seismic bed has to be provided either with the RCC, with the steel, or with the wooden part. Either it can be from bamboo or timber or whatever. So that because we need to tie the structure from all axes. So they can be from any material. And in the sustainability thing, that whatever is found locally, that can be used in a scientific way. Next page. Again, this is a bands. This can be used as a plinth band, lintel band, roof band. This is made of bamboo. So these can be used in mud houses. These can be used in timber houses. These can be used in stone houses. Next page. Now, factor affecting building in cyclone. The distance from the coast, height from high flood level and high tide level. Normally, what happens that people understand both the things are same, high flood level and high tide level, but these are different. And it might happen that during the high flood, high tide also occur. So it is recommended that while designing the building, it should be high flood level plus high tide level plus 150. So that should be the plinth level of the building. So correction between structural members are also important. Wind velocity and rainfall, because cyclone also comes with a heavy rain. Opening in all projections, soil conditions, shape of the building, and topography of the area. What happens that along the seashore, normally vegetation is high somewhere vegetation is low, somewhere building density is very high, somewhere building density is low. So if the building density is high or the forest cover is high, then they will break like a wind barrier. So wind speed reduces, the effect of the wind on the building is less. But if these are not there, then this is a tremendous effect on the buildings. So for the designing of the building for the cyclone, there is a factor called the basic wind speed and design wind speed. Basic wind speed has been given in IS 875, and design wind speed has to be calculated by using the terrain factor, and this all stands typology of the building. So there are factors like K1, K2, K3, K4. So design speed is calculated by multiplying basic wind speed with K1, K2, K3, K4 factors. Next slide, please. So best way to design affordable building is to design building in some shade from some hillock or some a forest. Zigzag planning has to be done to avoid wind tunnel effect, otherwise wind gains velocity in the straight line designing. Direction of the long face of the building facing wind is to be avoided. Normally in seashore, the high wind comes from the seaside. So seaside face of the building should be small one. Building should have deep foundation, firm soil, frame structure with a cross bracing, rounding and chamfering of the wall corners. Avoid roof projection, because what will happen? Then on the top there is a positive pressure, on the negative there is a negative pressure of the roof shades. So the roof just fly off. Adequate anchorage of the roof element. Construction should be very high, above high tide level plus high flood level, and building should be designed as per IS 875. Next slide, please. So ABCD of the cycle production generally known as A for anchorage, B for bracing, C for correction, D for detailing, and E for external environment. That is the key to design building for cyclone. A, B, C, D, E. Next slide, please. Basic wind speed reduced or enhanced due to factors like risk level of the structure in terms of adopted return period. Return period is very important. Return period. That for how many year we are designing a facility. If we are designing a facilities for say 50 years, then return period will be seen according to that. But if we are doing designing building for 1,000 years or very important building, then very long term graph of occurrence of events has to be seen. Next slide, please. So these are pictorial from which we distributed while working the earthquake, cyclones, and flood area in a vernacular language so people can understand all the jargons. Like if we design the building in the downside of some hillock, the effect of the wind will be reduced on the building. If we design building on the backdrop of some forest, like Casuarina forestation along the seashore, then the effect of the building, effect of the wind on the building will be less. So these are the basic, some gut feeling while choosing the site for designing of the building with different type of disasters. Next slide, please. The wall opening is also very important. How to open window in cyclones, and they have to anchor well. And probably in cyclone area, the wind shutter is not been casement type. It has been top hung, so that wind pressure without lot of effect on the structural members of the window. So next slide. Flood area. Again, for the design of the building in the flood area, the building has to be above HFL. Then building foundation needs to go below scouring level, even though minimum bearing capacity is available. But scouring level is important because if the earth is not there to retain the foundation, then all the structure will be washed away. Then some waterproofing element has to be provided in the lower part of the house. If this building is open to the corners, and these windows are very close to each other. So these are the factors which we have discussed earlier also has to be avoided as given in IS 4326. Next slide, please. So what design can we go back? Yeah, this one. Thank you, Dilip. For designing the building for flood, this plinth protection sort of the thing has to be there. Then the roof projection has to come out to protect the wall from the direct in contact with the water. If required, floor has to be lifted up for the Assam type of houses. This is the DPC and this is the depth of the foundation. Next slide, please. Good feature of flood resistant earthen construction. Foundation has to be above HFL by minimum 300 millimeter. Depth proof force has to be provided. Buttresses in long wall, the wall thickness, wall height, the distance from the opening from the corners, has to be kept. The waterproofing plaster has to be done. Next slide, please. Dissemination of do's and don'ts, which we distributed local vernacular languages in different part of the country in different disasters. Next slide, please. This is for earthquake. Next slide, please. This is, I think, in Gujarati. So during this 2001 earthquake, we distributed this pamphlet showing the basic elements, what should be done, how this should be done in Gujarati. Next slide, please. We also distributed few configuration of the houses, like this one is like a L1. This should be avoided. This is okay, rectangular one. This is again, here this is portion is weak, this portion is weak, this portion is weak. Here again. So we provided few good configuration. Here you will see some projection there, but some projection is allowed. But this projection is not allowed. This projection is not allowed. So we again distributed few type of configuration in different part of the country in vernacular language, that what should be done, what should not be done. Next, please. Like this trust doesn't have any, load transfer mechanism. This is not a trust. This is a lean to member. This is a proper trust. It's a tie, lefters. And this in the high wind area, this corner trust and the middleman trust has to be tied. Otherwise, this will fly off. This has already been covered in various in the standard how to design truss and how to tie truss with the load bearing members to prevent it from uplifting and flying off. Next slide, please. Like when there is a black cotton soil, then we need to provide some bulb so that in case of shrinkage or expansion, this should not uplift or go down. This is not allowed. Here, what is happening that one strata is going and this is suddenly expanding. They should expand slowly as per the required bearing capacity and as per the required load transfer of the building. Next slide, please. Here again, we have already discussed the issue that what is the long wall, how it should be broken, what are the joint, how the joint has to be taken care of by providing vertical and horizontal steel in the masonry. Next slide, please. Now this is called cyclone. Next slide, please. This corner will fly off. This has to be tight. If we keep larger opening, all will enter, wind will enter and will fly off. So this has to be taken care of. Next slide, please. Again, do's and don'ts. This is a typical truss type, and this is a pitch type. Pitch type is much better than the truss type as per the wind aerodynamics. Next slide, please. Like this is a unsymmetrical plane. This is a symmetrical plane. Here, what will happen? That wind will gain speed. When this will find a straight path, wind will lose speed in the zigzag form. So when we design building in Machilipatnam and Nagapatnam, after tsunami, we followed this pattern. Next slide, please. Here you see this is a frame without any bracing. So all the columns are, either long column or having high slenderness ratio, but they will provide bracing. Here again, what will happen that this window is opening casement type, which is not allowed, not recommended. The top hung windows are recommended in case of high wind or cyclones. Next slide, please. Now, do's and don'ts in flood affected areas. Partly this has been covered previously. that this is the part which we need to be protected from flood or water. So some plinth protection has to be done. The foundation has to be deep below scour level, and the plinth height has to be above HFL. Next slide, please. Again, the same story that the water will enter the house if we do not either lift it or put it on the high ground. Here, this is again a very unsymmetrical house in plan. Next slide, please. This is a very important building because when we were doing construction in Tholabera after this 2001 earthquake, and we told people that you can use the stabilized up block in combination with plinth band, lintel band, roof band, your house is not going to be collapsed. People did not believe us, and we do not have any shake table or shock table to demonstrate the effect of the small bends and the motors. So Professor Arya was our consultant. So he said that we will build a full house on the temporary platform, and then we will hit it by a tractor trolley. So two houses were built on the temporary platform, one with the beds and one without beds. So after the shock by the tractor trolley, the vernacular house, which was without any beds, got collapsed. You see in this picture. And the house built with the beds like plinth bed, lintel bed, eave bed, did not have much appreciable damage. So this gives a lot of confidence to the people that what beds can make a lot of difference in the house without any additional cost. So they immediately accepted. Seeing is more believing. So this was highly publicized and highly appreciable event in Tholabera. Next slide, please. Appropriate building construction technique for earthquake, cyclone, and resistant structure. BIS provisions. If we go for IS 4326, then we see the seismic zone 2 to 5. Again, there we have seismic zone 2 to 5 because IS this 1893/2025 has been repealed. And with the importance factor of 1 and with the importance factor of 1.5, the building has been classified as B2E and C2E. Next slide. So IS 4326 has given very thumb line recommendation that if you are designing building ABC, then use mortar 1:6. If you are designing building D, then use mortar 1:4. Next slide, please. Next slide, please. Yeah. And this is a very interesting, opening sizes also that one story AB, 60% opening is permissible, here 55%, here 50%. So all this has been very beautifully documented, written in a very scientific and very understanding way in IS 4326. You can get a copy. Now this is freely available on the BIS website and you can use. Next slide, please. They have also given that what plinth band configuration has to be there, what is their size, is 75 millimeter thick or 150 millimeter thick, what type of steel bar, what is their spacing, what is their stirrup, all been given in IS 4326. Next slide, please. They have given the detailing for vertical steel also. For example, if you are designing building category B, and my span, wall span is less than 5 meters, then I can use 2 number of 8 mm bar in the plinth band, 8 mm band. If my span wall length is more than 8 meters, then I can use 2 number of 10 mm bar. Similarly, building category E. So all things has been very beautifully given in IS 4326. Next slide, please. Vertical steel also been given that like in one story, if my building is category B, then I don't require vertical steel till three floors. In category B building, I don't require vertical steel up to 3 story. If I make a full story building, then from bottom to top, I require one bar of 10 and door at every corner junctions. Next slide, please. They have given configuration that how bar has to be bent, column and left between beam. And what is the LD, where it should be. These are very small details which we normally forget and leave it to bar bender, but these are ultimately very important factors. Next point. Next slide. The bar bending. This is a column and this is a beam is joining here, a beam is joining here. What type of my length of the stirrup? What is my hook size? What is my pedestal steel? What is my shear stirrup? All been given in IS 13920. Next slide, please. It is a very important thing. What happens that beam connections, beam column connections. So normally what has happened, because bar is here, this bar is at the same level. So bar bender turn the bar inside this column or beam and then expand the bar. But what will happen here, my moment of resistance become very less. Like this is shown here, what should be done. So this is the right way and this is the wrong way. Next slide, please. Again, this is a shading with the concrete that how it should look. Next slide, please. Again, the concrete shading. Next slide, please. It's strengthening the structure around the opening. We should be resistant A type, B type building, C type, D type building. Then what is the dimension and opening? Then all the dimensions between all the openings has been given. That these are the ideal one. If it is not the ideal one, then we require to strengthen by external ferrojacketing, micro concreting, steel rebar, carbon fiber, whatever. Next slide, please. Again, this is a pictorial form of building showing all the bends, horizontal, vertical, trusses members, cables. So this should be the ideal thing. Again, this picture we have distributed in Oriya and Gujarati and I think Tamil also. Next slide, please. This is the basic frame that how this stiffening has to be done. Basically, this is also used in Kashmir as a Daji Diwali system. What happened that people use the timber as a base and they put lot of crisscross member in that and they fill small pebbles and then they plaster it. This is called the Daji Diwali system and it has very great resilience in case of earthquake. What happens that because the member is having different structural members in all directions, so they absorb forces and pebbles are packed between them in a small size. So sometimes pebbles comes out, but their damaging effect is much less. Although the system is not covered in new standard. Next slide, please. Next slide. Again, this is a field one. Next slide, please. This is called the confined masonry. Now we have Indian standard on that how you confine the masonry by putting some steel members crisscrossly. Like when we put this horizontal bands like plinth band, lintel band, roof band, vertical steel at corners, jams, junctions, this also becomes somewhat confined masonry. Next slide, please. Critical points in pitch 2. They are like overhangs are very critical points. Openings are very critical points. So this has to be seen. Next slide, please. J bolts are being given, U bolts are given, how the truss purlins and tie members has to be tied with the wall. Next slide, please. Again here, where we have shown the U bolt, J bolt, and how they are being put up in the truss members. It is shown here in this picture. Next slide, please. Earlier I told you that what is the truss members. This ties are used to tie the bottom part of the truss of the end members. This is very, very essential. Next, please. Again, this is a vertical wall. Then this hooks are to be provided at regular interval. In the plane, these hooks are to be provided at a very regular interval, and this T point, T junction, has to be properly locked. So there are few repetitions in flood prone construction, this earthquake prone construction, and this cyclone prone construction. But there are some specialities like in flood protection, we have to go above HFL, foundation has to go below scar level, and this flood protection has to be there. In earthquake, the tiling is more important. Cyclone, the vertical projections are much more important. Next slide, please. Again, different type of wooden bands. Next slide, please. Yes. India is a big country with a total population about 1400 million now. Majority of houses in India are non-engineered, and a substantial part of this population lives in disaster-prone area. 70% population lives in villages, and there are no bylaws. Even in the urban areas, a lot of urban slums are there who do not follow any bylaws. The concentration of population is constantly growing in number of large cities, which are often located in high risk. Like Delhi is prone to earthquake, Delhi is prone to floods, Delhi is prone to cyclone. Indian standards have recognized the importance of local building materials and construction practices, and hence given the design values of bamboo, timber, mud, stone, low strength masonry, as well as method of improving their strength. Next slide, please. So we have to promote the affordable disaster-resistant technologies with the sustainable materials in human habitat. BMTPC has also published a lot of booklets on designing safe houses in different disaster-prone areas by using local materials and construction techniques. Next, please. Next. Next. impart training and do the model houses all over the country. For example, when we were working in Gujarat, when we were working in Odisha, when we were working in Andhra, when we were working in Tsunami area, we created some model houses using the local materials and local technologies in a scientific way and demonstrate the people that their houses can be made disaster resistant to certain extent by using the same materials, same technology in a very scientific way. So this gave a lot of confidence in them and buildings have been made as per that. Next page. Now, what we have done in disaster rehabilitation work using the local materials, same material almost, in a different way, like Latur, Jabalpur, Chaboli, Gujarat, Andhra, Odisha, Leh, and many other places. Next page. Next page. Next page. Like this is a famous gate designed by our ex-boss, Mr. M.N. Jublikar. This is called the Hatro Gate. Latur tragedy struck somewhere in 1993, and Latur was before that supposed to be a very earthquake stable area. This was known to be a Marathwada region located in seismic zone. One, nobody thought that any earthquake will struck this area, and there was no recorded history. People were basically farmers in this region who were growing grapes and they were storing their goods at their. But this area is very prone to high sun, so temperature dose is very high. So people used to give lot of insulation on top of their roof. So somewhere top of insulation thickness was found to be around 3 feet. So that has good amount of dead wood also. And houses were built with stone without any proper mortar or masonry techniques. So in case of shaking, all the houses collapsed like a pack of cards. Lot of damages took place. So after that, Hatko was given the task to design and plan 4 villages. But when Hatko reached there, we found that no good construction material is available. So what to do with that? The stone construction is very time consuming and very labor consuming. So we created solid and hollow concrete blocks on the site. The advantage of that they can be designed up to any required value, and because of their modular size, they can be transported easily and require mortar in a very small proportion. And hollow block gives the advantage that they are hollow, so bigger size can be casted, so lesser joint, and the insulation is also more because of cavity in that. So these houses were planned and constructed in 4 villages in Latur. And people were very happy to see their houses because they are engineered houses using the cement to certain extent, the steel to certain extent because roof was RCC pillar slab. So this work was done in Latur where we did not import anything externally except few amount of cement and few amount of steel. Next slide, please. Next slide, please. Yeah. You see that culture of Maharashtra, people used to sit in the courtyard. So the courtyard concept was developed and BIS IS 8888 was developed based on that. Everything was inspected on the ground and the houses were made as per the discussion and outcome of the local panchayat. Next slide, please. Odisha cyclone. Next slide, please. In Odisha, what is happening that soil bearing capacity was very less because this is prone to sea and water is saline. So there we used well foundations and the again cement hollow blocks and solid block were casted on the side using the portable machine, and villagers were involved in the casting of their blocks. Few blocks were tested on the site so that they can give confidence to the local people that these blocks are equally strong, in fact, more strong than burnt brick. And houses were constructed. So, a lot of primary schools, community buildings were constructed. Houses were less in Odisha. Next slide, please. Again, the Odisha buildings. All the earthquake beds, projections, openings provided as per the Indian standards. Next slide, please. I think this is a Paradeep. Next slide. Gujarat earthquake. Next slide. This was the village called Dholavera in Rampur Taluka in Kutch state, which is very close to Pakistan border, and this was the site of Indus Valley civilization, where we found ruins of Dholavera at that point of time, of that time. So this was the epicenter of the 2001 earthquake, where we could not find any good building materials, so we made stabilized earth block, local earth mixed with certain part of cement, compressed in this hydraulic press, and the bricks were used in the construction of houses, and roof were made with the RCC pillar slab, and veranda was made with manual tiles with precast rafters. RCC bands, RCC vertical steel has been provided in all these houses, and people were so happy now that now the name of the village is known as Hadko village. This was done, started in 2002 and got completed in 2007 or 8. Next slide, please. Yeah. So what happened in the front picture that this is the new house, but people retained their old house also. So this Bunga, normally called. So they retained Bunga, and this is the new house. These are all new houses. Next slide, please. What we did that till foundation, till plinth, we used the random rubble method. A good amount of stone was available, and people were trained in local masonry. So local stone was used in cement mortar. With some steel hooks and proper connection between the cross walls. And this is a vertical steel which is jetting out from the foundation. So this sort of construction was done in Dholavera. Next slide, please. And these are the earthen blocks which were constructed on the side by portable machine by the furniture, and they were tested. These are machines which is shown here. So they were tested on the site also, and people were extremely happy that they got the quality construction material, as well as they got the advantage that they got trained in making the machine, making the bricks, so that they can produce the machine and sell it. Next slide. These are the full furnished house in Dholavera. Earlier we saw the front part. Beautiful, arches, beautiful cobbling, door and window. These are the plinth band. These are the A band, the sill band. These are the plinth band, lintel band, and this is the roof band. Projections, and these are the precasted beams for putting MCR tiles. Not MCR, they were made the cement tiles. Next slide, please. Again, different part of the veranda in Dholavera, Gujarat. Next slide, please. Again, the house of the Dolabera. Next slide, please. Again, one more view. Next slide, please. This is their old house. They retained their roots. Next slide, please. Here the Bunga. Next slide, please. This is their morning and evening under a tree in the chopal. All sit together, gossip, take decisions, celebrate festivals, and organize community things. Next slide, please. This is the beautiful RCC filler slab. PMTPC has codified this filler slab, and there is a pack on that. The best part of Gujarat.
Doctor Saab, sorry to interrupt you. If you can wind up in 10 minutes, then we can have a question answer session for the next 5-10 minutes.
We can do so.
Thank you.
Next slide, please. I'll not explain the slides. Dilipji, please continue. Next slide, please. Next slide. This is the Jabalpur earthquake, which was the first urban earthquake after so many years. So people got shocked by Jabalpur earthquake. Although the damage was much less, but psychological impact was too high. We see what we did in Jabalpur. Next slide, please. This was the picture of the house which we saw in 97 in Jabalpur. Next slide, please. We created a small building center there to give training to the people to cast few building materials to be used in local construction. Next slide, please. We did few construction, few retrofitting, few modification in the houses in Jabalpur. Next, please. This is a tsunami. Next, please. Next, please. Next, please. Next, this is the actual picture of Nagapatnam. Yeah. Next, please. This is a very important factor that what to do with the fishermen because they have to live near the sea. Otherwise, how they can go to the sea to catch fish. But at the same time, we have to keep them safe from the high tide and tsunami also. So we created a buffer zone within the CRZ. And after that buffer, in the buffer zone, we created some small facilities so that they can store something and temporarily and create some jetties. And after that, they can come back to the safer places. Their houses are made in the safer zone. Next slide, please. So their houses are made. This is the buffer zone. This is the basic economic activity zone, and this whole area is buffer zone. After that, their houses are constructed. Next slide, please. We were able to give them only one room with the government money. So rest, if they want to expand their house, this is their bill that they can find land and can do construction. But we gave them one room set with the kitchen, and they want a toilet outside, so we gave them toilet outside like that. Next slide, please. I told you that wind tunnel effect, so to break the wind, and some casulina plantation was done in the buffer zone to shield the houses from the highway. Next slide, please. Lesson learned. A strong relationship between environment and development. The more we disturb the environment, the more destruction will take place. urbanization and urban growth. What we are happening in Gujarat, damages in Dholavira was less because homework construction was there. But in urban areas in Gujarat, damage was much more. Why? Because we did not follow the bylaws. We made soft stories, we made swimming pool in the terrace. What happened in Gujarat? This was in Gujarat. What happened in Maharashtra? That they made 3 feet, 4 feet thick stories on top of their roof. It collapsed. What happened in tsunami? They were putting up in CRZ zone. So we disturbed the nature, so nature took revenge and we could not do anything. So as we mentioned earlier that there are two strategies to deal with the natural disasters in a sustainable way. One is the land use planning and second is engineering. Land use planning is the foremost important. Until unless we understand what type of risk we are going to face, we cannot plan. The second is only then we know that what risk is there, what intensity, what probability is there, only then we can plan. For that thing, we have sufficient literature available by different codes of Bureau of Indian Standard through which we can design. And we have seen that engineering building faces very less damages in almost all the disasters. Almost all the disasters. Very less, yes. Few buildings failed like pack of card because of various reasons, engineering building. But generally almost all the buildings were engineering building were safe. Next slide, please. We did lot of good lessons also. Like Odisha, failure cyclone management was very, very commendable. People got good warning time. They were evacuated. They were placed in safe places, and damage to life was very, very less. So this is a good lesson which we learned in cyclone management. Next slide, please. So that's all. Thank you.
Thank you, Dr. Bansal, for such a comprehensive presentation covering the subject in such a great detail. I think the participants must have understood the details, how the disaster-resistant construction needs to be done in case of earthquake, floods, and cyclones. I personally feel that it was a very detailed presentation. And now I would request, I'm just checking the chat box if some questions are there in that. Otherwise, we can invite the participants to ask the questions. One question I'm seeing is, can fly ash material be used for cyclone prone area?
I think that I forgot to elaborate. This fly ash is a material, earth is a material, cement is a material. Fly ash is a pozzolanic material. Even the cement is the fly ash. So nobody stops using the fly ash. In Odisha, we did a lot of fly ash in construction. We add fly ash and cement concrete, and we use fly ash brick. Because fly ash is just a material. If you blend this fly ash with the other material, make a good brick. Then you see the properties of brick, not the fly ash. For example, even the building design with RCC gets failed. So RCC is not a material. It's a design, it's a construction. We should be, why? But fly ash is nowadays acceptable material. Why people are still doubting on fly ash now after so many years? Even the OPC is, not commonly available in the market. All the cement which is commonly available in the market, PPC. So why this doubt comes to mind? Yes.
Sir, may I put a question, sir? is how to fix, how to address the issue of putting non-structural elements in the supercyclonic zones as well as in the earthquake zones, zone 3 and above.
Yes, because I discussed some parapets and some projections, window projections, door projections. So these are the non structural elements which are very prone to earthquake and cyclones. In fact, Indian standard has given that whatever earthquake forces are to be applied on the building need to be applied 5 times more on the vertical and horizontal projections. So these are highly unsafe. So we need to anchor them properly as been shown in the do's and don'ts, and we need to take care of them as per the detailing given in do's and don'ts. It's all available. It has been shown there. But yes,
There
it's
will
a
be
highly.
lights are false ceiling and other things.
Sir, actually, I am dealing with affordable housing. You're of course right. False ceiling is very important, and this services in hospital like oxygen pipes and all are very important. So I know, but I am not expert on that, so I'll not comment on them. But these are their standard on that can be done. But I'm not. I'm my limitations that I work in affordable housing segment. So my priority is to give pakka house to all. So we should not give in case of earthquake, cyclone, or floods. So I have not personally given them false ceiling. I have not given them any oxygen supply lines or gas supply lines. So I cannot first hand deal with them. But if you go to Indian standard, there are good standards available on that, and they deal with the subject that how to tie vertical suspenders in the ceiling, what should be their size, what should be their spacing, how they should be tied, what should be the spacing horizontally, what should be gypsum board. So all are given, but I will not comment on that because I am not expert on that. Neither I have tried to touch this aspect in my presentation.
But sir, in PM Awas,
Yes.
the PM Awas, now this is a big challenging task to put PM Awas in large scale, particularly in cyclone and disaster prone areas. Particularly, I'm from Odisha. I'm from coastal Odisha. So this is in zone 3 and super cyclonic belt also. And for these two things, PM Awas, making a PM Awas and selecting the proper materials. If I'll go for precast, will it be better than cast in situ sort of thing?
Sir, precast has limitation because it requires minimum scale. So if scale is available, precast is a good material because this is a factory made product. So quality standard is all very high. But if you are looking for one house, then probably this is not. BMTPC did a lot of demonstration housing project in Odisha, Angul, lighthouse technologies. So they did it with rapid walls, they did it with light steel gauge, they did it with volumetric concrete, they did it with precast, they did it with almost all the technologies, different part of the world, different part of the India, including Odisha. So precast is a very good material, but it requires scale. If you have the scale, you can do it. There are 3-4 models in precast. One is the precast component, one is the precast full house, and is the precast volumetric. Fourth is the precast, the full printer based house. All are good. If you have the scale, you can do it. The economy comes with that, but quality standards are very high in precast compared to density. And regarding this, thermal comfort, if you talk about, and the thermal comfort can be taken care of by many aspects. One is that the microzonation of the site. If you do proper microzonation management regarding the plantation of trees, regarding the air intake in the house, air exchange, the thermal insulation, the shading device, so you can get good indoor air quality, good thermal insulation without any additional cost. That can be done.
There is one question in the chat box that how do the life cycle cost of resilient vernacular houses compared with conventional RCC houses?
Life cycle of the RCC in India is generally considered to be 60 to 70 years. So we are talking about the enhancement of their resilience. We are not talking about RCC construction as a whole. I've never covered RCC houses. I've talked about vernacular houses in this presentation. So their life cycle, if the normal life cycle is about say 70 years, then if you do this type of techniques like proper design, for example, foundation at proper level, the plinth height above HFL, HDL, and the wall ratios, wall height ratios, location of opening, the sizes of the opening, the plinth protection, the bracing in the house, then the life of the house will be definitely much more than the conventional houses, which is 70 years.
One more question in the chat box is, can we use construction debris mixed with the black cotton soil
Black cotton soil.
or backfilling as a backfilling material?
See, what is the black cotton soil? You need to understand what is the black cotton. Black cotton soil is an organic soil which expands when it comes in contact with the moisture, and it shrinks when moisture leaves it. So that is the black cotton soil. So in this type of soil, we need to design and plan the foundation, which should not be directly in contact with the black cotton. Otherwise, the black cotton soil will exert pressure on the foundation to go downward or upward or lateral in any direction depending upon movement of the moisture. For this thing, we normally do this underrain pile foundation with either one bulb, two bulb, three bulb, so that the pressure on the foundation is being resisted by the bulb in all three directions. So that's all. Construction debris has to do nothing with that. If you can plan foundation mixing with the construction debris as per IS 383, this is fine. Otherwise, if you want that, black cotton soil has to be fully removed and construction debris has to be filled in that, then there is no point because the cost economics will not work out. Construction debris can be used in the houses up to certain extent, which has been given in IS 383 and 456. That can be done.
Okay. There is one specific question for the lighthouse project and Indore, in which somebody has asked there is a lot of challenges due to some leakage in the joints. What is the solution to that? For that, I would request you to get connected with my colleague, Mr. C.N. Jha, who has been handling this project, and after getting these kind of leakage issues, he has been to the site, I think 2-3 times, and he has given the solution also there. In fact, there was a full team dedicated assigned this job, including the state government officials also. So I'm sharing his contact number in the chat box. I would request you to be in touch with him. Any other questions from the participants right now? As a GSTC award winner, I am working on making Humegi mortarless interlocking blocks micro to own their factories, make their own sustainable mixes, manufacture them with training and this is Mr. Torgerson. Are you there? Can you hear me? In fact, if you can come on the video, in fact, I was involved in doing in coordination of all the activities on behalf of BMTPC during the GSTC. and I remember that you have developed a motorless interlocking blocks. But my thing is that this is the first time after that we are in touch. And in fact, we have been sending some communication regarding using your product in our demonstration housing projects also. But as far as my knowledge goes, you have not been responding to our correspondence after the GSTC. But now you are saying that with training and certification through iHub and GBPN. Uh,
Yeah.
if you are in Delhi or if somebody from your side, because we are right these days, we are interacting with GBPN. In fact,
Good.
uh, in Delhi, and if somebody can come and meet us, and then I think we can work out further in this for anything if you are looking for.
Okay. Am I audible?
Yeah, sure, very clear.
Okay. Yes, I am in the U.S. and I'm planning to come to India to push this to do this initiative, and I can tell you more offline. I can tell you more later. But and I have someone in India who can meet with you. But this is a really exciting project.
Yes. We in fact, this is very, because it is a interlocking blocks, and I think they are interlocking and holes are there in the blocks, if I
Yes,
remember correctly. It's a
very
perforated
versatile.
interlocking blocks.
Yes,
And we also, because they will perform very good for the thermal insulation also, and there is a saving in material also, and if they fulfill the criteria of strength and other parameters for the block to be used in India, I think this was identified as one of the very promising technology for India, in fact. And as I told you that we have been trying to contact somebody in Humangi, but somehow we were not getting any response from your side. This is good that you have come today and joined this webinar. And if you are coming in the near future to India, please meet us, and we can work out how we can take up this technology further. Or if
okay,
you,
very good.
if you can ask GBP and people to come and meet before that, whatever is comfortable to you.
Okay, very good. It is a long story, and we had COVID in between as well, but um, I'm
Yeah,
glad to have this
that is fine.
communication.
Yeah. Okay, then we will see you when you come to India, and then we can work out how we can take it further.
Yeah, and I will send you information in the meantime.
Sure. Thank you very much.
Thank you.
Somebody has put a question that, sir, is there any IS code or papers to use construction debris mixed with black cotton soil as backfilling? I don't think there is any Indian standard on that. Using construction waste and mixing it with black cotton. Dr. Bansal? I think Dr. Bansal network issue is there. But to my understanding, there is no Indian standard.
Sorry. To my best of knowledge, I mean, I have not seen any code on this subject.
Yeah.
Sir, can I speak?
Yeah, sure.
I'm Bagrodia.
Yeah, Bagrode sir.
Sir, I am actually from IIT Kharagpur, and I am an innovator and particularly for construction, and developed a lot of technologies. But most unfortunately, I find a lot of response from the government departments and all that. So, like you were talking about bricks, I was working with NBCC for their C&D waste, plant, and I worked for this, and it was a very good plant. But after that, I find such great difficulty to talk to MCD and other people, that why we shouldn't use this technology, and it's making such good bricks out of waste. Number two, I have a green technology for making roads, and guarantee 10 years of life. Now, I have my this technology is also approved by road CRRI and addition with this IRC, and still I find it so difficult to promote this in PWD and all, and they don't talk and all these things. So same thing with anti-corrosion coatings. I have developed anti-corrosion coatings for. I'm approved by RDSO for making anti-corrosion on steel structures, and I give guarantee of a very long time. And I'm the only one approved by RDSO about 15 years back. So things like that, I would request you to let me know as to how I can promote, because I'm now 82-year-old. Still, I'm doing it for the reason that I want to do something for my country, all these good technologies. So I need your help as to how I can promote these technologies and forward.
Dr. Bansal, if you permit me, I would like to answer this question.
We are just a practitioner. So we follow whatever good practices, but the codes are available. So if you know, you can send me your literature. If you find that this is can be used, we will definitely use it, and we'll give you a bit comment on
Definitely,
that.
I'll send it to you. You let me know your email ID or whatever, and
Yes,
I will love to.
And in fact,
send you.
Bagrodia Sahab, you can always, in fact, there is a scheme run by BMTPC by the name of Performance Appraisal Certification. And this scheme is basically for these kind of new materials which have been invented or researched in India or from even outside, which those products which do not have any Indian standard as on date. So we certify these projects under the Performance Appraisal Certification Scheme. And I would also request you to send these details to BMTPC also. And in case these materials can be considered under this scheme, we will revert you back. So I am also sending you the email ID of Mr. C.N. Jha, who is looking after the packs. You please send the details to him.
I will.
Any other question, please?
I think that some question came that flood affected area in Assam. Kindly suggest construction techniques for houses that can survive water, stilt, and strong currents. Must be affordable for the villager. I think that Assam type of houses which are built on bamboo are the good solution for that, which is affordable, traditional, sustainable. Only the intervention required is that we can see the sizes of the bamboo to be used for making stilts, bracing, and height of the houses, which should be above the highest flood level. So that is the best sustainable conventional technique with the intervention that the sizes of the members and bracing and the height that can be done as per the requirement of the houses.
Yeah, I think this is the last question we had, and we come to the conclusion of this webinar. And on behalf of BMTPC and myself, in fact, Dr. Bansal is a dear friend, and we have been neighbors in the sense that HUDCO and BMTPC office is just in front of each other. And since I joined in '99 BMTPC, I have been interacting with Dr. Bansal, and we have also been involved in many projects and discussing all these technologies and new materials over a period of time. And good to have Dr. Bansal today in this webinar and sharing his knowledge and experience with all of you. And so I, once again, on behalf of myself and BMTPC, I thank Dr. Bansal.
तो 45 मिनट उसका नहीं होगा।
क्या आपका फोन कुछ कहना चाह रहे हैं somebody? नहीं। So I thank Dr. Bansal, and I thank all the participants also. We normally keep these kind of webinars once in a month, and again we will be having on a new topic next month, and we will be sending you the invitation for that and request you to join for the new topic. And even if you don't have any questions right now, you can always write to BMTPC. We can direct those questions to our expert speaker, and they can also reply. Dr. Bansal has already shared his email ID in the chat box. If you want to write a direct question to him, he would be happy to clarify those questions also. And on behalf of BMTPC, once again, I thank all the participants also, and also Mr. Rick from US, from Humangi, who has also joined. And it's a long time that now BMTPC has been able to be in touch with the Humangi, and hopefully we will be doing some future work on the technology they have developed. With this, I close this webinar, and thanks to all of you. Thank you very much.
Thank you, Pankaj.